Hi, can you hear me okay? Great. All right. So we'll get started. My name is Alex Zambelli. I'm a media technology evangelist at Microsoft. And today we're going to talk about the Microsoft Media Platform. And I'm going to talk first a little bit about how it got to be. And then we're going to talk about what the components are of the Microsoft Media Platform. And then we're going to dive into some of these components and talk about the recent product releases and updates, and then some of the upcoming product releases and updates as well. So I'm guessing that you're at this session because you're interested in media delivery, video streaming over the internet, those kind of concepts. And so you probably will remember some of this, because what we're going to do first is we're going to take a little time travel back to the year 2003 when Microsoft released the Windows Media 9 series, if you remember that. And this is basically what the state of video streaming was in 2003. So we just released Windows Media 9 series, and the workflow typically in those days was that you probably started by encoding your video with Windows Media Encoder 9. You encoded it to the Windows Media file format, or ASF file format as it was officially known. You probably used Windows Media video codecs and audio codecs to do that. And then you might have protected your media with Windows Media Rights Manager. And then you probably used Windows Server 2003 with Windows Media Services to deliver that video to a Windows Media Player client, which was back then, if you're delivering to a web page, it was an ActiveX object embedded in your web page. And you probably used the RTSP protocol or something like that to deliver that video. And then when you finally were done, you got this amazing looking video, which was like 320 by 240, and it was running at 15 frames per second, and you thought, wow, this is amazing. This is the best thing I've ever seen in my life. And, well, now we know better. But it was great for its time. I mean, this was really 8 years ago that we're talking about. But times have changed, and the world has changed. And so in order to understand what the Microsoft Media Platform is today, it's important to understand how exactly has the world of video streaming changed in these past 8 years. And so one of the first things that happened was we saw rich internet media applications replace media player-specific plugins on websites. So a long time ago, 8 years ago, we had media player, real player, QuickTime players. You got a website, and one of these would be embedded in your page if you had it installed on your machine, and that's what was used to play the video. So they were native plugins embedded in web pages, and they were typically done specifically a particular browser, whether it was IE or Netscape or when Firefox came out. And so we had the emergence of Flash and Java, and then eventually Silverlight replaced this with more richer applications. They weren't just media players; they're really web applications that just happen to do media as well. The other thing that happened was really the explosion of user-generated video. And it kind of concurred, it came at the same time as the growth of social media. First, MySpace, then later Facebook. It's hard to say which one came first, which one fueled which one, but they were definitely related. Another thing that happened was that all our internet connection speeds increased. 8 years ago, you were lucky if you had like a megabit and a half DSL connection to the internet, and of course today we typically have much bigger bandwidth than that at home. As well, the CDN coverage increased. So we had more content delivery networks with greater coverage around the world. They deployed more edge servers and more HTTP caches around the world, so they were actually able to deliver any kind of data in a much more scalable way with far greater reach. And they also realized that not only could they deliver text and pictures and just regular data, but also they started using HTTP more and more for delivering video. And really, proof of that was YouTube. I mean, YouTube was the one that really kind of popularized the concept of a site that used HTTP, and that was the only method they used for delivering its video. YouTube never used RTSP or any other kind of really streaming protocol. Another movement that we saw in the last decade was that the video industry started converging around H.264 and AAC as their really primary go-to codecs. And it started out in the video industry with Blu-ray and HD-DVD at the time as well. And then we saw that really kind of cross over into the streaming industry as well. And then finally, there's been the emergence of smart mobile devices, smartphones, and then tablet PCs and tablet devices like the iPad that have really changed the way we look at delivery of video today. It used to be that if you wanted to reach your customers with streaming video, you pretty much had to just hit the PC and the Mac and you were done. And that has changed. Now, of course, if you don't deliver your video to your iPhone users, your Android users, your Windows Phone users, it feels like you're not really hitting all your customers. And of course, the speed of the networks increased as well. So streaming high-def video to a phone was just a dream 8 years ago. And today, with 3G networks and 4G networks, it's absolutely a possibility. So really, the consequence of that is that cross-browser, cross-platform reach has become essentially a requirement for video delivery over the internet. And so in response to that, Microsoft has, Microsoft responded to this changing streaming media landscape with a number of technologies. So we released Silverlight, we released IS Media Services, PlayReady DRM, Expression Encoder, IE9 browser, Windows Azure. And with these technologies, what we were able to do is we were able to enable cross-browser, cross-platform media applications, specifically with Silverlight and HTML5 support in IE9. With IS Media Services, we were able to enable, that sounds funny, HTTP-based media delivery. And then with PlayReady DRM, we were able to encrypt and protect video in a way that was codec agnostic and platform agnostic. So no longer we were tied to just the Windows Media format. We could really go and protect, H.264, AC codecs as well, and other formats such as MP4. And then finally, Azure enabled, the cloud computing and services and delivery of data, as which includes video from the cloud. So all these technologies, all these products that we released in the past 8 years, they work great together, and we use them on a regular basis. You might as well to deliver video over the internet, but they also are modular enough to really create an open ecosystem where components can be used individually, or maybe just 2 or 3 of them, are used at the same time. So you don't necessarily need to use Silverlight and IS Media and PlayReady and Expression, all this stuff together to make it work. You can sort of pick and choose which one fits your needs. And that's really where we are today. So what we're doing actually this week is formally acknowledging that we've had a media platform that's a second generation Microsoft Media Platform for the past several years. And maybe we didn't call it Microsoft Media Platform, but well, now we will. And what Microsoft Media Platform is, it's really an umbrella brand for a group of Microsoft products and frameworks that really work well together to form Microsoft's state-of-the-art media delivery solution. But also, as I said, they're kind of autonomous products as well, and they can be used individually as well. So it's a formal acknowledgement of something that we've all sort of known for the past few years, that we have this media platform that works great. With the Microsoft Media Platform, it's also going to be easier to really identify this group of products, because we're really talking about vertical integration. We're not going to go and rename any of these products. It's not going to be suddenly Microsoft Media Platform Encoder or anything like that. They're still going to be called what they are because they still individually have their own roles. But vertically, they're definitely integrated as the Microsoft Media Platform. And of course, as a result of that, we're going to get better brand recognition, as well as just a better way to aggregate our technical resources. So one of the problems we had in the past is if you wanted to learn about streaming media with the Microsoft platform, you probably heard that you could deliver media to the Silverlight client. So you'd go to the Silverlight webpage and you go look for some articles and technical resources about how to do that. But then on the Silverlight site, there was no mention of how IIS Media Services works, because that was on the IIS Media site. And so we've had this problem over the last few years. So this is our attempt to really solve that and kind of bring it all under the same roof. So as a part of this soft launch that we're doing this week, is we're launching a site on Microsoft.com/media platform, where this is, if from here on, if you want to find out anything about the Microsoft Media Platform, that's where you should go first. And any Microsoft product, whether it's Silverlight or Expression Encoder or whatever that's used to deliver video using the Microsoft Media Platform, you'll find information about here, and we'll talk about, specifically about the media features of those products and such. So Microsoft Media Platform components, what are they? So as you can see, on the services side, we have, of course, IIS Media Services, which is an extension for IIS-7 running on Windows Server 2008. And it's a free extension. It's a free download. And this is what we use to deliver media using HTTP. In some cases, that might be progressive download HTTP. In some cases, predominantly, really lately, it's been adaptive streaming or HTTP, which is our smooth streaming technology. Another component which we consider a part of our services offering is Windows Azure. And you'll see it become more and more relevant in the future because a lot of these components, inevitably will start moving into the cloud. So on the tooling side, if you want to encode your media, our solution for encoding your media to smooth streaming or MP4 or WMV or whatever is the Microsoft Expression Encoder. It's not the only encoder you can use because we have partners that we work with that produce other encoding solutions that support smooth streaming output, support obviously H.264 AAC output, and so on. And so it's not the only tool. Microsoft PlayReady is our DRM solution. This is basically what you use to encrypt and protect your content. And it exists, calling it a tool is maybe not given enough credit because we offer it as a server SDK, so you can actually create services based on the PlayReady DRM. We offer also encryption tools, so it is a tool in that respect. And then also we offer client SDKs for the PlayReady DRM, which can work both on Windows as well as non-Windows platforms. If you're targeting certain platforms and clients with a Microsoft Media Platform, sort of our primary for the past few years has been Silverlight. Certainly that's our richest internet media experience. Then with the IE9 being released was it a month ago, IE9 now has support for HTML5, so we're going to see that become also increasingly used for delivery of media. And then finally, I mentioned that we have porting kits available. So our smooth streaming technology, which is our HTTP-based adaptive streaming technology, is not just limited to delivery to Silverlight. We actually offer a smooth streaming porting kit that can be used to deliver smooth streaming natively to iOS devices, Android devices, Linux devices, and so on. And the same goes for PlayReady. So PlayReady, we also offer a client porting kit for PlayReady, which allows you to natively decode, decrypt protected content on non-Windows or non-Silverlight, should I say, clients. And so that's really become an increasingly important option. In fact, just recently, last week, Comcast made an announcement that for their Xfinity TV catch-up service online, they're actually using smooth streaming and PlayReady porting kits to build a native iOS app that runs on the iPad. And so if you're watching Comcast Xfinity on your iPad, you're actually watching smooth streaming and PlayReady protected streams. There's no Silverlight on the iPad, but it's still playing back due to the porting kits that we offer. And then finally, the last part of the Microsoft Media Platform is the frameworks. These are derivative frameworks. All of them are open source that we built to really kind of tie some of these components together. So we have the video editor, and I'll go into detail about all these, but the four that you see on screen are the fours that we have available right now or will be releasing in the next month or so. So I mentioned that the Microsoft Media Platform is flexible in the sense that you can use exclusively Microsoft products to deliver video online, but you can also have a more open workflow as well. So this is an example of what will be a Microsoft exclusive workflow, where we're just using Microsoft products, in this case, to deliver video. So we start by using expression encoder 4, for example, to encode the video to smooth streaming. Then we take those smooth streaming files and maybe we hand them over to the IIS transfer manager to apply DRM protection to it, which uses PlayReady, DRM. So then we take those files, we put them on a Windows server running IIS Media Services, and we use IIS Media Services to deliver these files using smooth streaming over to the client. We use the Windows Azure CDN, for example, to distribute the content down as far as we can down to the edges. And then finally, we use Microsoft Silverlight-based player application to play back the content. So this would be an example of just a Microsoft exclusive workflow. But we can also be more open than that. So if you don't like expression encoder, if it doesn't meet your needs, you can use their other solutions out there. So we work with a number of partners. So we work with InLED, which is now part of Cisco, Digital Rapids, NVIDIA, AnyStream, Rosette. Many companies out there make encoder products. They're professional encoder products that now support smooth streaming output, for example. And so you could use, for example, a Digital Rapids encoder to, again, encode your video to smooth streaming. And then, if you don't want to do your own encryption or your own protection, you could go pay, a service provider, a DRM service provider such as BuyDRM, for example, to protect your media. They apply PlayReady encryption to it, then they host it on a Windows server with IIS Media Services, and then maybe they use, maybe you end up using level 3 CDN to distribute that media down to your client. And in this case, maybe that client is an iOS-based iPhone or iPad that's running smooth streaming porting kit and PlayReady DRM porting kit on top of it. So that's really the gist of the Microsoft Media Platform. And I guess really the main takeaway here is that we're not trying to launch any new Microsoft Media Platform products necessarily. We're doing vertical integration. We're basically taking products that we've been using for many years now to deliver video online, and we're lining up under this common umbrella brand called the Microsoft Media Platform. So let's take a deeper look at, closer look at some of the product updates related to the Microsoft Media Platform. So I mentioned Windows Azure as being increasingly important in this platform. So Windows Azure CDN is our CDN that's a part of the Windows Azure platform. And they're going to be announcing that by May this year, they're going to have a technology preview available of smooth streaming VOD services running on Windows Azure CDN. So what it essentially is, it's a turnkey solution for delivery of smooth streaming using the Windows Azure CDN. What that essentially means is that you're going to be able to take your smooth streaming encoded files, put them in a public CDN-enabled blob, and then have it just work and not have to worry about setting up your own hosting servers or paying another CDN for the same service. And so this is going to be a pay-as-you-go service that's a part of the Windows Azure CDN. Like I said, there's going to be a CTP, a community technical preview, available by May of this year. So the other component, obviously, that's very important on the services side is the IIS Media Services component. Our current version is version 4.0, and we just released that back in December. And the new features that are in version 4.0, probably like the most important one is the ability to dynamically repackage smooth streaming into Apple HTTP live streaming format. The way this works is because we're assuming in this case that you're using H.264 and AAC as your codecs in your smooth streaming streams, and those codecs are, of course, supported on both the Silverlight platform as well as the macOS platform as well. The iOS platform. So assuming you're using those codecs, the reason why we can just repackage these streams without actually having to re-encode them is because the only thing that's actually different is the file format in this case. So smooth streaming uses MP4-based file format, whereas HTTP live streaming uses a MPEG-2 transfer stream-based file format. So by simply remuxing repackaging the video and the audio payload, we can actually go from smooth streaming to Apple HTTP live streaming without having to re-encode the streams. So encode once and then deliver to either a server-like client or to a Windows Phone client or to an iOS client. We support features such as live DVR. We support archiving, AES encryption. That's a part of the Apple HTTP live streaming specification. It's not the same thing as player-rated DRM. It's just AES encryption. It's a part of HLS. And then the other feature that we have in version 4.0 is low latency live smooth streaming. If you ever tried doing live smooth streaming, you probably noticed that typical end-to-end latency in a live smooth streaming event can be, anywhere between like 20 seconds to 40 seconds, maybe more depending on the CDN. And in a lot of cases, that's just not acceptable. If you're doing a live sporting event or something where it's really important that you deliver, results on time. Or another example would be if you're doing anything related to financial news, where it's important that your stock ticker is not a minute behind or something. So there are scenarios where low latency is expected and required. So we have a low latency feature now as a part of IS Media Services that when you're using a compatible encoder, the encoder has to support the low latency feature as well. You can actually reduce this end-to-end latency down to 2 seconds or less. Another cool product that we're releasing, which is right now a separate download. It's still considered a part of IS Media Services, but it's still not a part of the main IS Media Services package, is something called Transfer Manager. So right now it's a separate download just because it's still in beta stages. This beta is going to be released by end of April. And what it is, it's a way of automating the process of both transcoding, transmuxing, packaging, so that you can run it on a server and set up basically watch folders where you deliver maybe some sources in one format to that watch folder, and it automatically goes and either gets transcoded or transmuxed or packaged or whatever you need. And you can actually even chain these tasks so that you can do both transcoding and transcoding and packaging one after another. So out of the box, we support expression encoder, but you could really set up tasks that use really any third-party encoder to do your automated transcoding. The transmuxing that I'm mentioning, that's similar to the live dynamic repackaging feature that we have for live streams. This is really the same thing, but for VOD assets. Taking the smooth streaming of VOD assets, repackaging them to Apple HLS format. Player-ready packaging, I think that's pretty obvious what it is. So it's just the applying of encryption and DRM protection to smooth streaming content. Oftentimes, that's a part of the encoding process, but there are scenarios where you might want to encode content, leave it in the clear, and then apply DRM after that because maybe you want to deliver both in the clear and protected. And then finally, a feature that I really like, actually, of the Transfer Manager is it supports transmuxing from just plain regular MP4 files to smooth streaming. Smooth streaming is based on the MP4 file format, so it's actually very similar. We impose more constraints on the way we encode smooth streaming because we encode to multiple bit rates in smooth streaming. We require that they actually be time aligned, that keyframes are aligned, and some other requirements like that. But let's say you're using an encoder that doesn't support smooth streaming output, but does support MP4 regular file output. You could actually, if you can impose those constraints, like I said, just make sure your keyframes are aligned and such. You could encode to several MP4 files, several bit rates, several resolutions, and then basically put them in a folder, and the Transfer Manager will go and produce smooth streaming output based on those MP4 file inputs. So it's a very cool feature. It allows you to really use any H.264 encoder out there that you want to use, whether it's open source like X264 or FFmpeg, or something commercial that just doesn't support smooth streaming output yet. Another announcement that we're making is the availability of our smooth streaming client porting kit that I mentioned before. So it's now available for licensing, and if you're interested, there's the email address that you can actually send inquiries to. What it is, it's just a C, C++ based SDK that you can use to build smooth streaming players on non-Silverlight platforms or non-Windows platforms even. It's actually, I mentioned that there's already companies building smooth streaming players using the supporting kit on the iOS. There's also companies like that are putting in or considering putting it into consumer electronics devices, set-top boxes, and things like that. It's not, the important thing to understand about the porting kit is that it's not a full player. It's not like the Silverlight Media Framework or something that has all the bells and whistles. It's really just the transport layer that knows how to download the chunks, knows how to parse the manifest, knows how to basically parse out the H.264 and the AAC payloads. And that's really all it does. And of course, there's the heuristics part. It knows how to vary the bit rates, how to actually adapt to the network conditions, the CPU conditions, and such. That's really what the smooth streaming porting kit is. After it gets the H.264 and AAC video out of it, then it hands it off to the local hardware to go decode and render and so on. So it's not trying to replace the whole thing. And as I mentioned before, Comcast just recently adopted this and the PlayReady porting kit to deliver smooth streaming, protected smooth streaming files to their Xfinity TV app on the iPad. Expression Encoder, like I mentioned, is our in-house encoding product. And so the most recent version is 4.0, and we just released a service pack for that 4.0 release back in January. Now, with the Expression Encoder, it's kind of funny. Every time they do a service pack, they really put a lot of features in that service pack. And so these are really more like .5 releases than they are service packs. So a big feature that went to the last service pack is support for hardware-accelerated H.264 encoding. So if you have like an NVIDIA card, for example, that supports CUDA, you can accelerate your H.264 encoding by offloading some of that to the GPU instead of just encoding on the CPU entirely. And the H.264 feature is only available in the Pro version. So if you want to check it out, you do have to buy the Pro version. It's not in the trial version. Another feature that's in the last Expression Encoder service pack is HEAC audio support. That's for encoding to mobile devices. So both Windows Phone 7 and the iPhone support HEAC decoding. It's really just a more efficient way of coding your audio so that you can use lower bit rates such as 64K, 48K, or 32K to deliver much higher fidelity audio than you can with just regular AAC. There's other features that went into the service pack. I won't talk about all of them. Live screen capture, better denoising, and so on. And of course, there's Silverlight. Tomorrow, as you probably know, we're going to be releasing our Silverlight 5 beta. And the Silverlight 5, I'm just going to talk about the media features going into Silverlight 5 because this is a media session. There are, I'm sure, many sessions that you can go to tomorrow to find out everything else that's going into Silverlight 5. But the Silverlight 5 beta is going to have hardware GPU accelerated H.264 decoding, which if you're ever tried to decode the H.264 video like on a netbook that has an Atom processor or something, or older computer, you know that it kind of chokes on it because H.264 decoding is more demanding than VC1 decoding and some other codecs. So this feature is going to go a long way to really enable playback of H.264 video on netbooks that have GPUs that support this feature. I believe that's right now the NVIDIA-based netbooks and the AMD-based netbooks, and then I think Intel support is coming soon as well. And then the other feature going into the beta is, it's media-related, is the variable speed playback. If you've ever had to watch one of those boring, like corporate education, sessions that your company makes you watch, what is it, like conducts of business, standards of business conduct, yeah. Any of those sessions, you know that they're boring and they last forever, and it'd be nice if you can just kind of fast forward your way through them. So that's what this feature is. It's really the ability to fast forward your video and watch the 1.5 speed or 2x speed and so on, or watch it or rewind it and so on. And then there's some features going into the final version of Silverlight 5. They're not in the beta yet. It's support for DRM key rotation, which is the ability to change your DRM encryption key halfway through the stream. which is important for live events. They go on for a long time, but they still want to ensure that their content is always protected with a fresh key. And then remote control support, the ability to control applications with a remote control, such as if you're trying to build like a media center type of experience. Internet Explorer, I'm sure you've heard plenty about it today. IE9 just got released last month, and it supports many HTML5 features, among them video and audio tags. The video and audio tags that we support in IE9, so natively we provide support for H.264 and AC decoding from MP4 files. We also actually, well not we, but we worked with Google to have them provide a WebM plugin that you can install and then have IE9 support playback of WebM files as well within the video and audio tags. I want to mention that IE9 and the HTML5 video audio tags work really well with the IS Media Services bit throttling feature. It's a feature that went into the very first version of IS Media Services. And what it is, it's this feature that allows you to control how fast the server actually delivers media data. Because in a typical scenario, if your server, web server is delivering just regular data, say a JPEG file or something, you always want it to be delivered as quickly as possible, obviously. But in the case of media, that's not always the best thing to do. If you think of YouTube, for example, how many times have you gone to YouTube to watch a video that somebody sent you a link to, and you started watching it, and about like 10 seconds into it, you thought, nah, you know what, I don't care about this video, and stopped it. And then if you actually looked at how much of it loaded in those 10 seconds that you were watching it, you might have loaded all 2 or 3 minutes of the video, depending on how fast your connection was. So that's a waste of your bandwidth, and that's a waste of YouTube's bandwidth, which means somebody's going to pay more for that video that got delivered but was never watched. So there's actually scenarios, in the case of media, where you want the web server to deliver not so quickly. And so what the bitrate throttling feature does, it sort of does the initial burst, delivers the first 10 or 15 seconds of video really quickly, and then slows down and tries to actually keep up with your playback speed. So it natively supports MP4 file bitrate throttling, but it's also extensible to the point where you could configure it for the WebM format as well. If you're interested in doing this, talk to me later, because I'd love to actually see somebody do this. You just have to figure out where all the properties are in the WebM file, and that's all it is. So I want to talk a little bit about HTML5 and its relationship to adaptive streaming. We talk a lot about HTML5 because obviously it is very important for interoperability. But the important thing to understand that A, it's still in work and draft stage, and B, that like the specification, the part of the specification talks about the video and audio tags is actually fairly vague when it comes to, well, it really just lacks specifics on a lot of things. So it lacks specifics on codecs. I'm sure you all heard that discussion. Should we use H.264 or WebM or some other codecs and so on? Really lacks specifics on file formats, transfer protocols, live streaming, DRM. There's really no standard DRM to use in HTML5. And so among things that it doesn't specify is also adaptive streaming. Now, I say that, and you might be thinking, well, wait, I was just delivering adaptive streaming video over HTTP to my iPhone to an HTML5 page. Well, how does that work? Well, just because the spec doesn't mention it doesn't mean you can't add it. So Apple, in this case, for example, has added support for their HLS, HTTP live streaming, which is an adaptive streaming method, to their implementation of HTML5 on Safari, and on iOS. And they can do that because, like I said, it's not specified, so I guess it's technically not being in compliance with the spec. But it also, the thing to understand is that it's not a standard part of the HTML5 spec either. So right now, there really is no standard way of doing adaptive streaming to the HTML5 video and audio tags. But it's not a dire situation because MPEG and 3GPP are actually currently working on standardizing HTTP-based adaptive streaming. There's actually, these are two related standardization efforts. They're pretty much identical. They're just happening in two different standards bodies. So MPEG-Dash and 3GPP AHS are standardization efforts to standardize HTTP-based adaptive streaming. I don't know when they're going to be finalized, but when they are, we are actually likely to align smooth streaming with those standards because those standards are based on the fragmented MP4 file format, feature a lot of features that exist today in smooth streaming. So it's actually very similar to the technology we already have today. So when they're final, we will likely align with those. I don't know when W3C or if they're going to adopt that, but really if we're ever going to have standard adaptive streaming in HTML5, that would probably be the route to go down. So the last part I want to talk about today is the frameworks that compose the Microsoft Media Platform. So I mentioned that frameworks are sort of this glue that holds a lot of these pieces together. Because if you ever try to do a live streaming event, you know that's not easy. It's not just a simple matter of, well, I have an encoder, and I built my player, and I'm good to go. You know that there's, you have to go configure that encoder. You have to go set up live publishing points. You have to go start and stop the publishing points. You have to start and stop the encoders. You have to, once that video is actually going across the network, you have to understand what's exactly happening with it, where the error is occurring. The cloud tends to be a little bit of a black box when it comes to video streaming. A lot of times you just kind of send it out there and hope that it arrives at the client, but who knows what happens. And so really to solve a lot of these issues, we started working on these frameworks. And we have a player framework that we use to obviously build very rich media players using Silverlight. We have a content manager that we use to provide like a basis for running these type of live events and for managing VOD assets. There's a video editor framework that we provide for doing what we call rough cuts. They're essentially, they're rough cuts. They're a way of editing your smooth streaming video without having to re-encode it. So just by chopping up the manifest in the right places, you can actually edit videos together without having to go and re-encode the whole thing. And the additional advantage of it is that it just stays where it is. It stays in the cloud. You don't need to go re-upload assets anywhere. And then finally, we have a framework called Audience Insight, which is our way of tracking data related to playback and delivery of video, and really kind of eliminating a lot of the noise and figuring out, what exactly, where is our audience, who's our audience, what kind of experience are they getting, and so on. So the Microsoft Media Platform Player Framework is actually our new name for a product that we previously called Silverlight Media Framework. So you're probably maybe familiar with the Silverlight Media Framework. So right now we're just renaming it, but we're actually considering adding support for HTML5 in the future as well. So it's really going to be a player framework that goes beyond just Silverlight. The latest version is of the player framework is 2.5, and it just got released on Sunday. And it features two really cool features. One is stereoscopic 3D video support, and the other one is support for various advertising standards that we have in the online industry today. The stereoscopic 3D video support, we're providing like a classic red cyan anaglyph plugin as a part of the player framework. And then we worked with NVIDIA to have them provide a plugin for the player framework that enables NVIDIA 3D Vision, which is an active shutter glasses-based 3D system on the PC to work with Silverlight as well. It's extensible architecture, so other ways of rendering 3D video are possible as well. We just, right now, we're providing only these two output options. The advertising support is really our way of providing support for MAST, VAST, and VPaid in the Silverlight Media Framework. And I really encourage you to check out a session on Thursday called Player Framework Past, Present, Future. Tim Greenfield from Vertigo Software is going to be presenting this session. It's at 9 a.m., so I apologize for that. I know it's a little bit early, and you're probably going to be up late on Wednesday as well. But I really, really highly recommend this session. If you want to find out more about the latest version of the Player Framework, formerly known as Silverlight Media Framework, I encourage you to go to that session. So we're announcing a framework today. This is really the first time we're kind of formally talking about it. It's a new framework. It's called Content Manager. And it's going to be available sometime in the next month or two, depending on how soon we can actually get it out the door and get through all the reviews and everything. But basically, it's a lightweight content management system for managing both live and on-demand streaming events. So it's the asset management part of it is based on the SharePoint platform. The on-demand transcoding is based on IIS Transfer Manager. And besides just managing VOD assets, it manages also live events. So it provides you the ability to, like I said, create publishing points, start them, stop them, reset them, do it all, on a timeline. And then obviously to also accordingly stop and start your encoders as well. And then the other thing it does, it provides integrated ad insertion support. And it also integrates the video editor framework to allow you to do cloud-based video encoding. So it's a really, really rich content manager. The goal of it is not necessarily, there's many CMS solutions out there, and the goal of this is not to replace them. It's really just to provide, a sort of a baseline framework for doing this stuff, because in a lot of cases, you either have to build it from scratch, or you have to take an existing CMS and really adapt it to, this particular workflow. And this is just our way of, trying to solve that problem. There's a session here at MIX tomorrow on Wednesday by Steve Woodward, and he's going to talk about the Content Manager in depth. And if you'd like to learn more about it, I recommend that session as well. So the Microsoft Media Platform Video Editor is a product we formerly called Silverlight Rough Cut Editor. And I always thought Rough Cut was maybe not like the best name for it, because it's a concept that means something in the broadcast industry. You're doing a rough cut, but it doesn't necessarily say video editing to the average consumer. So that's why we renamed it. And also, as you can see, we were aligning all the frameworks to say clearly Microsoft Media Platform, so that they're a part of the platform and what they're used for. So the latest version of the video editor is 1.0 Service Pack 1 that just got released this January. And Service Pack 1 provides, an improved setup experience, provides support for specifically Silverlight 4 runtime, and it uses the latest Smooth Streaming Client SDK. It provides CSM compression. CSM is our composite stream manifest format, which is what you get when you combine multiple Smooth Streaming manifests into a single one. That can often lead to sort of a explosion in size of your manifest, and so the latest version of the video editor provides CSM compression as a feature. And also there's other improvements going in there, like CPU performance and so on, that are improved since the previous version. So it's a really cool product. It's one of those products that really showcases Silverlight as a client platform at its best. If you've never seen it in action, I recommend that you go to a session tomorrow as well. It's a mini session at 2 o'clock by Jason Seuss. And it's a really, really cool product. It's seriously, you're going to go and you're going to see it in action and you're going to go, wow, because it really makes the process of editing video online so easy. The fact that you could edit online video from any desktop machine or any laptop or whatever that has Silverlight installed, and you don't need to have anything else installed on the machine, and you don't need to move videos from the cloud to your machine or anything like that, it's really cool. Another framework that we're announcing today is our Audience Insight framework. And so we're also going to be releasing that sometime in the next month or two. And so what it is, it's basically a software and services framework for scalable, cost-effective, real-time tracking of what's happening with your media as it's being delivered. This is an issue, like I said, when you're delivering media, oftentimes it's a black box. You know you're delivering it, but you don't know who's watching it, and you don't know where they're watching it. You don't know what kind of playback experience are they getting. Are they getting a lot of buffering, a lot of errors, disconnections, and so on. And so this is the framework that allows you to actually visualize that data and really weed through all the noise that you typically get in that kind of logging. It's built on top of the SQL Server Stream Insight framework. So I invite you also to another session where you can find out more about the Audience Insight framework. and that's on Thursday at 10:30 a.m. by Eric Schmidt. So he's going to talk in depth about the audience insight framework. So that is really all that we have today. We have about 15 minutes left, and I'm open for questions now and hopefully answers too. Gentleman over there. How does it tie into the Silverlight Net movies? Enhanced movies, yeah. So the Silverlight Enhanced Movies is another framework that we have, which we haven't really publicly released yet. And the idea of Silverlight Enhanced Movies is that it allows you to build out-of-browser movie playback experiences where it sort of takes the DVD Blu-ray concept and puts it on your desktop, or really puts it online, I should say. The idea is that you download this package and you play back and you get exactly a DVD type of experience with all the menus and all the extras and director's commentary and multiple languages and all that stuff right there on your computer versus having to go and buy the physical DVD. So it's definitely related, and I think at some point you might see us sort of integrate that into the Microsoft Media Platform as well when it's ready for public release. Right now it's still in trials, and we're still testing it with the studios and seeing what the interest is like. So, yeah, I can see that being integrated with the Microsoft Media Platform one day. So the question, if I understand it, is whether there's a way to control the encoder and transfer manager through an API-based approach? Right. Okay. Yeah, so the expression encoder comes with an SDK. When you install it, I think it automatically installs the SDK as well. And basically every feature that you have in expression encoder in the UI version is available, exposed through the SDK as well. Yeah, and in fact, the content manager framework that we talked about, that actually uses that SDK to talk to the expression encoder. And then in the case of the transfer manager, I believe there's also an SDK exposed there as well, because that's sort of the idea behind it, is that you really want to run it in the background in an automated way without having to log into your machine and go move files from one folder to another, pick presets and do all that stuff. So it's really trying to provide a hands-off approach to transcoding where it's just kind of happening in the background and you set up once and you're good to go. Any other questions? Yes. Right now, encoding is not supported in Azure. I believe that you can go and deploy, a VHD that has expression to Azure, but we don't offer it as a service yet. So I guess the answer is that yes, you could do it, but we don't offer it as a service that's a part of Windows Azure that you just go and pay for, and it's there. I'm not sure I can answer that. I'm not sure because we don't, like I said, we don't offer it as a service yet. And I think if you're deploying your own image to Azure, I suppose at that point you're responsible for your own licensing. But I don't know much more than that. Go ahead. Yeah, so right now so to start with, we're going to support just VOD smooth streaming delivery through the Azure CDN. Live, we're looking at live as well as potentially supporting that. There's a lot more complexity involved with live just because you have to, obviously you have to be able to provide endpoints for the encoders to connect to. You have to also be able to handle a lot of, a lot of data really coming into the blob, making sure that the disks and the machines can handle all that. So there's a lot more complexity to it. We're definitely looking at it, and it's a possibility. But for right now, we're just announcing the VOD availability. Go ahead. Mm-hmm. That's a very, so the question is there any player implementation on top of the smooth streaming and play ready pointing kits? The only customer cases we had so far, was where somebody like Comcast went and hired a third party to build that player for them. Now, I'm not aware of anybody building a player and just kind of making it freely available or making the framework freely available or publicly. Or publicly, yeah. So I'm not aware of it, but there might very well be companies out there building players for iOS or Android based on these pointing kits. So it's certainly a possibility. So really, anybody who can license the pointing kit can go build that and deploy that. But unfortunately, I can't name any names off the top of my head right now. And if anybody does know the answer, then come and talk to me afterwards, and I'd love to know who these companies are. Go ahead.
Are there any direct show filters that we can use to play back smooth streaming files on the desktop?
Okay, so the question is, are there any direct show filters to play smooth streaming on the desktop? Right now, I'm not aware of any. There's a filter that comes with Expression Encoder. Then when you install Expression Encoder, there's a direct show filter that enables you to play back the local smooth streaming files, so the ISMV files that are on your disk. But I'm not aware of any direct show filter that will let you do smooth streaming from the cloud, the actual smooth streaming with the variable bitrate and everything. That said, with the porting kit, the smooth streaming porting kit being available now, somebody could very easily build that by just wrapping that C++ code in a direct show wrapper, and there you go.
I mean, is there a reason why that's not available? Is that down to DRM and things?
There's no particular reason why it's not available. It's just none of the teams, because on one hand we had the IS Media Services team was really focused on delivery to Silverlight because that is the most typical and most popular option. So that's where they focused their resources. And then the Expression Encoder team really enabled the direct show filter for the local scenario because that's the scenario they were interested in because they wanted to be able to import smooth streaming files into their product. So nobody's really tackled it just because it wasn't a part of their immediate roadmap. But it's certainly a possibility, and anybody who can license the smooth streaming client porting kit can go build that filter really today. And that's another thing that I'd love to hear more about. So if you're interested in building that, come talk to me. Any other questions? Yes.
Silverlight has the capability to allow the user to store video locally and interact with the application back.
Mm-hmm.
When we do that, can you give us an idea of what sort of download data rate comes? Or is it programmatic or limiting that? Or is it going to be the highest data rate? And if so, does bitrate volume play a role there that might mitigate the impact of that?
So if I'm understanding your question, it's about just the smooth streaming playback functionality, or the fast forward and rewind and.
No, the smooth stream download capability for local playback, for playback.
Okay.
When that happens, how does it perform on the download?
I see. So just to clarify, you're talking about downloading a smooth streaming single bitrate file to your disk, or are you talking about just playing back multiple bitrates and adapting as you play?
Well, I think it downloads only one bitrate. That's what I wanted to check. That's a little story.
Oh, I see. So when you play a smooth streaming asset, whether it's a live or VOD asset, in the say using the player framework, it automatically varies the bitrate as you go. So it adapts to both your network conditions and your CPU conditions based on how much you can handle. The way it does it is it downloads the video in chunks, so it does it in 2-second or longer chunks depending on how it's encoded, but typically it's 2 seconds. So every 2 seconds of video get downloaded at a time over HTTP. And every 2 seconds it can evaluate the speed of the network, how whether your computer's keeping up with the frame rate and so on, and so it can decide to either shift up or down in bitrate. For a typical HD asset, you might have 6 or 8 bitrates available. For an SD asset, there might be 4 or 6, typically, and so that's how it's done. Does that answer your question? Okay, thank you. Any other questions? We have 5 more minutes, so we got plenty of questions left. Yeah. Yes. To just, okay, so the question is there a way to download? Okay, I see. To take an ISME file and download it? That's an excellent question. So yeah, so the question is there a way to download a smooth streaming asset to your disk and then play it offline? There's one way to do it, so it's actually part of that Silhouette Enhanced Movies framework that we haven't yet publicly released, but that does allow you to cache everything that you know, as you're playing a video from the cloud, it allows you to cache all those fragments on disk and then play them offline at a later point when you're disconnected. But the question I think that you were asking, is there a way to just take like a single bit rate? Yeah. Uh-huh. You could control that. So there's a way in the Silverlight client, in the smooth streaming client, to limit which bit rates you want to play back. So if you have 6 bit rates available, you can actually say I only want the top bit rate to play back, and then essentially just have it download and cache. Obviously, if you don't have the bandwidth, then it's going to be kind of stop and go. But if you have enough bandwidth, then yeah, that will work exactly like you described. I'm sorry. Uh-huh. It's not very reliable. Oh, it's just selecting and keeping it there.
It tends to, if you keep a range of bit rates, it respects the higher bit rates not selected, the lower bit rates not selected. It tends to go down.
I mean, you can select specific tracks. So if there's 6 bits available, you can say I just want the middle 3, for example.
Yeah, we're running that for HBO projects.
Okay. Mm-hmm. Okay, I see, yeah.
We had to go with a posted rate that wouldn't respect.
Yeah, I mean, it definitely, if you're restricted just to high bit rates, but you can't keep up with those high bit rates, then yeah, you might run into some issues just because the way it's designed, it's really designed to provide you with video at all times as opposed to stopping and going, rebuffering and so on. But we can talk about that afterwards because that's something that we're actually considering at providing better options for those type of scenarios where users care more about watching it at a high quality than just watching it without interruptions. So that's something that we're actually discussing about how we can enable that scenario as well. Because right now it's definitely tuned for the scenario where you're watching a video, like a movie from Netflix, for example, or something like that, where you don't want to stop. Right, you just want to keep going for 2 hours, the length of the movie, without having to rebuffer, and you don't necessarily care if the quality goes up and down a little bit. But we should talk more about that because we're actually looking at that as well. Yes, go ahead.
The older Windows video streaming, you had a built-in capability of the network speed very tight. You would drop video and just go live.
Yeah. So the question is there a way to just drop video and keep only audio when the network conditions worsen so much? Because there was a feature that existed before in Windows Media Streaming. So right now that's, I believe, not supported. I'm looking at the back row over there, right? I think we require still video. Some of the Vertigo developers are back there, so I'm looking at them. Yeah. Yes, yeah. So you could, that's one way to work around it. You can encode, a bit rate that's, 20 kilobits. That's just like 16 by 16 pixels, and then use that, just not show it, and then just, make sure that it doesn't get displayed other than in those conditions. So that's one way to work around it. But right now, by default, we don't drop to audio only. It is again another feature that we're looking at adding to like future versions of the smooth streaming client and the player framework as well. Go ahead.
Windows Media Services used to support the time code streams.
Mm-hmm.
Are you planning to support something the same way smooth streaming?
Yeah, so we actually have quite rich metadata support in smooth streaming. We support, for example, text streams, which is non-video, non-audio tracks to be embedded both into the stream as well as the manifest itself. And so you could embed the timestamps in there, but the timestamps are actually by default already embedded in the manifest, especially if you're doing a live event. Most professional encoders, like the inlets and the NVIDIAs and Digital Rapids, they will embed the real-time clock time code into the manifest. Because for live events, that's important because you need to be able to actually control when you start and stop your events, and so on. So There is a timecode that goes in there, but for VOD assets, if you're talking about like SMPTE timecode and things like that, then the encoder would need to support that. But the format, the switch stream format does support it today. It's just really a question of whoever's implementing the encoder of adding that feature to their encoder. And then on the player side, extracting it. For the player framework does have a way of parsing, any text stream out of the source, and then you deal with it however you want to.
You don't mind supporting like video player natively?
I'm sorry, I didn't hear that question.
You're planning to support that natively in video player, so the time we get.
Okay, natively, like out of the box. So that's potentially a feature that we could add to the player framework. If we were to add it somewhere, it would be in the player framework most likely. Not like in the serverless runtime client, it would be in the player framework. But that's something that we would definitely consider if there's enough demand for that. It's all about demand, right? Limited resources. Any other questions? I think we got 50 seconds. No, we're over time. Never mind. So, okay, I guess that's it.